Assalamu alaikum viewers, I'm Dr. Arshad. In this video, we'll discuss the complex numbers. At the end of the video, you will be able to know what is a complex number, what is the real and imaginary part of a complex number. Also, you would be able to find a conjugate of a complex number. Then we'll discuss equality of complex numbers. At the end, we'll solve exercise 2.5 of the class 9 math. First of all, we define a complex number. It is a number of the form a plus b iota. Here a and b, they are real numbers. For numbers, I'll shortly write NO, and if it is plural, then NOS. And this I, this is called iota, and it is equal to square root of -1. So any number of the form a plus b iota is called a complex number. Generally, we denote a complex number by the number z, like z is equal to a plus b iota. Let's consider some examples of complex numbers. For example, we may have a complex number of the form 2 plus 3 iota. Here we see that 2 and 3, they are any real numbers, and iota is the number which is equal to square root of -1. Second example, we may have a complex number of the form -5 minus 6 iota, or we can have z is equal to 2 by 3 plus 7 iota, or we may have z is equal to 5 iota. Then we can also have z is equal to -3 plus iota, or we can have z is equal to 6 minus 3 iota. The set of complex numbers, this is denoted by the capital C. Now we consider real and imaginary parts of a complex number. For example, if z is any complex number a plus b iota, the number without iota, this is called the real part. This one, this is the real part, and the coefficient of iota, this is the imaginary part. Mathematically, we write RE, that is for real z is equal to A, and IM for imaginary part of z is B. We can see that any real number can be written as, for example, if A is any real number, then we can write A as z is equal to a plus 0 iota. That is, the imaginary part is 0. Thus, every real number is also a complex number. Thus, we can say that the set of real numbers, this is subset of the complex numbers. Next, we discuss the pure imaginary number. If the real part of complex numbers is 0, that is, if z is equal to b iota, in this case a is equal to 0, then this is called the pure imaginary number. Z is a number of the form 0 plus 0 iota. That is, real part is 0, imaginary part is also 0. Then we can write it as 0. Now we define a conjugate of a complex number. For example, if Z is a complex number of the form A plus B iota, then its conjugate of Z is given as Z bar is equal to A plus B iota bar equals A minus B iota. That is, after taking conjugate, the sign of the imaginary part, it is, if it is positive, then it becomes negative. That is, we take the additive inverse of the imaginary part of the complex number. If it is positive, then we get negative, and if it is negative, then we'll get positive imaginary part of the given complex number. Let's consider some examples. If we have a complex number 3 plus 2 iota, then its conjugate, it is given as Z bar. We can write directly the conjugate of Z without writing a bar over this number. That is 3, and we'll take the additive inverse of the imaginary part. This is positive 2, so we'll get negative 2 iota. Similarly, if we have a complex number of the form 2 minus 4 iota, then its conjugate is we'll take additive inverse of the imaginary part. In this case, this is negative 4, so the conjugate, in the conjugate case, it will become positive. That is 2 plus 4 iota. Third, if we have a complex number of the form, just if it is only a pure imaginary number like 6 iota, then the conjugate becomes negative 6 iota. And if we have a complex number whose imaginary part is 0, that is, for example, we have a 4, then its conjugate remains the same complex number. Here, this complex number can be written as Z is equal to 4 plus 0 iota. So, if we take the conjugate, then 4 minus 0 iota can be written as just 4. So, if we have only a real number, then the conjugate remains the same, and if we have a pure imaginary number, then it becomes the negative of that number. If it is positive, becomes negative. And similarly, if we have, for example, a complex number like minus 2 iota, then its conjugate becomes positive 2 iota. Now we consider equality of complex numbers. For example, if we have two complex numbers like Z1 is equal to A plus B iota, and Z2 is equal to C plus D iota. Here A, B, C, D, they are any real numbers. Then we say that the two complex numbers are equal. That is, Z1 is equal to Z2 if and only if real part is equal to the real part. A is equal to C and imaginary part is equal to the imaginary part. That is, B is equal to D. Thus, we can simply write that two complex numbers are equal if real part of Z1 is equal to real part of Z2, and similarly, imaginary part of Z1 is equal to imaginary part of Z2.